All right, so this question says, which ordered pair does not lie on the graph of this function? So first of all, this is written in function notation. So remember that really this is no different than if you wrote y equals negative 2x plus 7. So function notation is just a way that you can show what the input was, what the value of x was that you plugged in. And so what they're wanting us to do is to take these x, y ordered pairs and plug them in to the function and see which one is not true. So let me just show you, and it'll probably make more sense. So for this first one, so this is answer A. They want you to plug in a negative 2 for x. All right, so I'd have h of negative 2 equals negative 2 times negative 2 plus 7. And actually, I shouldn't have written that. Look at this. So what should go here is what the y value is. So the y value is 3. And so what I did here is I plugged in negative 2 for x. So that's where this negative 2 came from. And I plugged in 3 for y. So this is the input, this is the output. And so now I'm just looking to see, is the left side of this equal to the right side? And so if I do the math here, 3 equals negative 2 times negative 2 is 4 plus 7. So I end up with 3 equals 11. That's not true. So the answer is actually A. So when you plug in negative 2 into the function, you don't get 3 out. So you really wouldn't have to do any more, but let me just show you B. So on B, my x, here's my y. I plug in 3 for x and 1 for y. So 1 equals negative 2 times 3 plus 7. Again, I've just plugged in a 3 for the x. So 1 equals negative 6 plus 7. 1 equals 1. So that point does lie on the graph of that function or that equation. And if you did C and D, those would also be true. So what you're looking for is the one that doesn't work in that equation. All right. So quick review of the general steps for solving equations, and these are also the same for solving inequalities. So remember, when you solve inequalities, the only difference is if the variable is being multiplied or divided by a negative number, you have to flip the inequality. So these are general steps. There are some times where these steps don't follow exactly. So for instance, let me show you one of those. So let's say I had 2x plus 3 over 4 equals 6. In this equation, this is really one of the few I can think of that doesn't follow these steps. When you have something like this, the first step is actually to multiply both sides by this number in the denominator. So you would multiply both sides of this by 4. That would cancel out that. Then you'd have 2x plus 3 equals 24. And then you would continue on from there. Okay, so this is an example of one that doesn't follow these steps, but most of them do. So the first step is to distribute, and that's only if you have distributed property in the problem. This one does, so here's distributed property right here. So that's what we're going to do first. And so then we get 2x plus 6 plus 4 equals 3x minus 6. The next step is to combine like terms. And remember, you can only combine like terms that are on the same side of the equal sign, on the same side of the equation. So I can combine this 6 and this 4 together here. So I combine those together, and I get 2x plus 10 equals 3x minus 6. Then the third step, if you have variables on both sides of the equations, which this one does, then you want to get them on the same side. And you do that by adding or subtracting. So I could either subtract 2x from both sides, or I could subtract 3x from both sides. I usually choose what's going to give me a positive outcome. So if I subtracted 3x, I'd end up with a negative x here. If I subtract 2x, I'll end up with a positive x. So I'm going to subtract 2x from both sides. So those cancel out, and I'm left with 10 equals x minus 6. And then at this point, you should have just a 1 or a 2-step equation. And so from this point on, you just use opposite operations to solve for the variable. This is just 1 step left, so I just add 6 to both sides. 16 equals x, but you should flip that around and write x equals 16. And remember, you can always check your answers when you're solving equations. Plug this in for x and see if the left side equals the right side. All right, absolute value equations. So in an absolute value equation, you always want to get the absolute value piece by itself if it's not already. So that means I want to get rid of this minus 4 here. So I'm going to add 4 to both sides. And I have the absolute value of x plus 3 equals 7. Now, remember, absolute value, just come over here on the side, the absolute value of 7 is 7, and the absolute value of negative 7 is also 7. So absolute value always has a positive number that comes out of it. So that means that what's inside of these parentheses could be, or not inside the parentheses, inside the absolute value could be a 7 or a negative 7, because they're both equal to 7. So this is where you want to split this up. So you write 2 equations. One equation is x plus 3 equals 7, or x plus 3 could be equal to negative 7. Because the absolute value of 7 is 7, the absolute value of negative 7 is also 7. And then you solve these 2 equations, and you're going to end up with 2 answers. So there's one of my answers. And the other answer is x equals negative 10. Now, remember, if you get an absolute value equation and it's equal to a negative number, then that's no solution, because the absolute value of something can never be negative. So this isn't possible. So there's no solution to that. All right. So let's jump to solving inequalities. And again, remember I said there's no difference from solving inequalities and solving equations, except if the variable is being multiplied or divided by a number, you have to flip the inequality. So we have to flip the inequality on this one. So the first thing I'm going to do is rewrite this. Now, some people like to do this at the end. I like to go ahead and do it now so I don't forget. So I went ahead and I flipped the inequality because the variable was being multiplied by a negative. Now I solve this, excuse me, just like I would solve a regular equation. So minus 3, minus 3. So now I have negative 2d is greater than negative 10. Divide by negative 2. D is greater than positive 5. And remember, for the graphs of inequalities, 0, 5, negative 5. If the inequality symbol doesn't have a line underneath it, meaning or equal to, then you use an open circle. So an open circle at 5, because my answer was 5. This says D is greater than 5, so that means I shade to the right. So I'm showing all the values that D could be, any value greater than 5. You can also use this as like an arrow pointing which way to shade, but remember that only works if the variable's on this side. All right, so absolute value inequalities. So this is the exact same problem, but one of them's less than, one of them's greater than. So I wanted to show you the difference between these. All right, so let's first get the absolute value piece by itself. So minus 3, minus 3. So the absolute value of 4x is less than 8. So remember that absolute value, the definition is a number's distance from 0 on the number line. A number's distance from 0 on a number line. So what this is saying is that 4x is less than 8 away from 0. 4x is less than 8 away from 0. That means that 4x is in here. And this is what an AND looks like. Remember, compound inequalities can break into ANDs or ORs. So this is what this inequality looks like. And so what I'm going to do is write the compound inequality that's represented by this picture. So the left side says that 4x is greater than negative 8. That's this. Shaded to the right, that's where I get the greater than. This other one over here says 4x is less than positive 8. So that's what this represents. Less than, because it's shaded to the left. And now I solve these two. And again, this is an AND. So I divide both sides by 4. So x is greater than negative 2. And divide both sides by 4. X is less than positive 2. So you could write your answer like that. Or with an AND, you can write it like this. Put the smaller number here, the bigger number here. And you have these inequalities. So this says the same thing. X is less than 2. That's this piece. X is greater than, alligators eating X, negative 2. So your answer could be written in either of those forms. Only ANDs can be combined like this. Okay, so let's look at what happens when you flip the inequality around. So again, my first step is to get the inequality by itself, or not the inequality, the absolute value. So the absolute value of 4x is greater than 8. So that means that 4x is more than 8 away from 0 on a number line. Now, you don't have to draw this number line. I just think that it helps me to visualize what's going on, and it helps me to write the inequalities that result from it. More than 8 away from 0, so that would be this way or this way. And this is an OR. So ORs graph like this, ANDs graph like this. And so now I'm just going to write the two inequalities that result from this. So 4x is less than negative 8, or 4x is greater than positive 8. So this comes from this, and this comes from that. Then I solve these, divide by 4, divide by 4. I can do both of them at the same time. So x is less than negative 2, or x is greater than positive 2. And you can't combine those together like you can with an AND. All right, so let's see what else I have. Okay, so this is a compound inequality. This is an AND, because only ANDs can be written like this. And so this is actually two inequalities, and so what you want to do is break this apart. So I have one inequality that's right here. So that says 18 is less than 3x. And I have another inequality over here. So 3x is part of both of these. So 3x is less than 36. So you just split this apart into its two inequalities and then solve those two inequalities. So on both of these, you're dividing by 3. Divide by 3. Don't forget, if the variable was being multiplied by a negative, I'd have to flip the inequality here, so don't lose sight of that. So 6 less than x, x is less than 12. And so this is an and, so you could leave your answer like that, or you can put it back together like this. So x is greater than 6 and less than 12. So the graph of that, so here's 12, here's 6. These are open circles. Greater than 6 and less than 12, that's here. That's how an and always graphs. All right, I got one more for you. Similar figures. So in similar figures, the way that I taught us to do this is to label one of them top and one of them bottom. And I usually label the one with the X as my top and the other one as my bottom. That's just to guide me in setting up the proportion. So these values will go in the top and these values will go in the bottom. So I like to put T on the side that has the X because I like to put the X in top. And then in the bottom, I put which side matches up with X. That's called its corresponding side. So X corresponds with the 9. So I put X over 9. And then now I can use either 9.6 or 8.4. It doesn't matter. So I used X and 9. Now let's use 8.4 and 7. And again, the reason I labeled these top and bottom is to make sure that I put the 8.4 in the top. So to keep these straight. As this, you have to be consistent in how you set this up. So X corresponds with 9, 8.4 corresponds with 7. Remember, to solve this, you can just multiply the two diagonal numbers and divide by that number. So you would just do 9 times 8.4 divided by 7, and you should get, let's see, I think that comes out to 10.8. All right, so I hope that was helpful to you. Till next time.